Okay.
At the very least.
Good afternoon, everybody. How was your week been? Good? Alright. So, actually, if you read the fine print, you're not going to be a ninja, but anyway, but the whole point of this is to give you just a basic overall analysis of sort of what malware analysis is, you know, and so that for people that maybe work in SOCs and things like that, being able to take you from knowing nothing to maybe being able to do some basic malware analysis. Now, if things get very complex, you probably, you know, then it's time to hand it over to the people that do things like forensics and malware analysis full time. But that's me on Twitter. I'm from Nova. Is anybody from DC or this area? Only one? I talked to several people. I thought they were from DC. No? Okay, guess not. So I got into security probably in the early 2000s, doing web app security. So a lot of fun, a lot of great things going on there. Very interesting. To this day, the field just fascinates me what people can and do. But unfortunately, for career reasons, I had to move on. Things like, you know, security engineering, they were paying well, and so, you know, I went from actually doing stuff to actually just creating documents and things like that. And then I got into a little bit of this. You know, and unfortunately some of that, you know, and then I was creating a lot of this, you know, but at the same time there was all this cool stuff that was going on, and I was creating this, and it was sort of driving me nuts, and I wanted to do this. So I thought a little bit, and then I'd say, so for the past 2.5, 3 years, I've been doing more trade study sort of stuff. I still do some of, you know, these fun things, props and CNAs and stuff like that, but at least I'm, you know, at least getting some hands-on skills doing stuff. So I'm still creating this, but not as much, and I'm drinking better versions of this. So in the evening, on my own time, I try to do, you know, learn as much as I can about all the different community tools that the security industry has out there, trying to just do more hands-on stuff. So I kind of try to showcase that on a website that I run, novainfosec.com. Just sort of pay the bills, you know, just want to give thanks out to several of the groups that sponsor Milton Security Group, Bob Security.
Hey, Bob,
where's she? And also TrainAce. And I know we had the talk earlier on the small business security stuff, and I know Milton Security, they actually have some good products that are built for small businesses, just nice appliances. So I heard this topic brought up, so you know, always sort of looking for people that want to help contribute to the website, maybe going out and researching different security tools and writing about them, or if you just sort of just want to write about the news and things like that. You know, no money, but, you know, as I've been in the industry for about 18 years now, so you know, mentorship and can kind of maybe help you take the next step into transitioning into your into information security, or helping you take it to the next level. And if you're in the DC area or you want to move there, it's kind of an instant in meeting a lot of the key folks that are in InfoSec within the DC area. So just hit me up on Twitter at Grecs, right? So I've kind of tipped enough, right? But so at the end of all this, I'm happier. So kind of getting some of the meta material, just a quick intro, talk about the environment that you need for doing malware analysis, the methodology. I basically have 3 steps that I try to take. Well, 3 steps, and then within each step there's like 20 steps, sub-steps. But and then where to learn more, because you're not going to listen to this talk and at the end of it, you know, be a ninja. So kind of next steps. and then conclusion. So just warning, whenever you're doing any sort of malware analysis, be careful. Don't do stuff on production systems. Me, myself, I'm not necessarily a malware expert. I can do the basics, and I'm continuing to learn more. So sort of like I'm learning a lot and learning a lot more by giving talks like this to kind of help other people just establish that foundation. So environment-wise, there's kind of two different ways. You can either have a physical setup or a virtual one. Obviously, with physical can be kind of rough, but it is needed in some situations. But most people that I know go virtual, so they basically use a product like VMware or VirtualBox or whoever, and you can set up VMs. Then there's physical. What? Yes.
Yeah. Every now and then I hear people saying that you shouldn't use virtual systems for analysis because people will make the malware be like VMware.
Yep. Yeah. That's something that, except you have to consider too, with VDI, things like that. Like a lot of people, their workstation is running in a VM. So, but if you run into something that is very tough, I mean, obviously you can be like, oh, this is a special case, let's bring it over to our physical box. So, I mean, you definitely need to have, like, if you're a malware analysis shop or a SOC or something like that, you can do most of your stuff on in a virtualized environment, but you're probably going to have that like kind of one-off physical box that you may use in rare occasions. Kind of within, regardless of the network infrastructure that you have there, the two options is you can either just have your single box, so that's where you take the malware and you put it on the box, run it, and you kind of do all the analysis on that same box, or you can have a dual, plus box. So you can have 2, 3, 4 boxes, and that's mainly to emulate, let the malware think that, oh, I'm on a network and I can reach out and call to my CNC channels, but except you're kind of faking it. So those, most people, they just start out doing single box, and I'll talk about some of the different apps that you can install that help a single box act more like a dual box setup. And I already talked through some of these, but pros and cons of each. So the virtual, very easy to set up. You can do snapshots, so you can run the malware, do your analysis, and then maybe you'll miss something, so you can revert back and rerun it. So you don't have to do the whole OS install from scratch each time. So it makes it very easy. And we already talked about this, malware being able to detect that it's in a VM and then being able to act differently from or just terminating. So that's an issue that you may have to consider. And then that's where you need that sort of one-off physical box where, but obviously having a bunch of different physical systems set up to analyze malware is more resource intensive. So it depends on the size of your shop. I mean, I think for doing malware analysis 101, I mean, you're basically going to probably use on the cheap. You're going to probably use something like VirtualBox, and you're going to have some VMs that you can run up. So this is just some quick setup steps. Usually, and I have VMware on my Mac. Kind of one of the things that I want to point out here, I mean, obviously whenever you're running malware, on the VMware stack, there's 3 types of networks. So there's NAT, which, I mean, who doesn't know what NAT is? Hopefully no one raises their hand. Okay. So there's NAT. Network address translation. So that basically, instead of having an IP that's on the internet, it's natted. So you usually have something like 192.168.1 dot something or 10 dot, and it's a private, non-routable address space. So there's bridge, which is you're basically connected to the you're getting an actual IP address, and there's host only. So obviously, whenever you're running malware and playing with it, you would say, oh, I only want to run host only. But you have to be careful with that, because host only includes not only the guest VMs, but also the host that everything's running on. So just sort of in setting that up, these are just some quick steps. Like, you want to create a new adapter, and then let's see, you create a new network interface, and then you connect the VM to that adapter, and you want to make sure that that it's unchecked. Connect the host MAC to this network. You want to make sure that's unchecked. And it's just pretty similar to a lot of the different VM packages out there. And then here is where you're actually setting it up to use this custom one that you created versus host only. So in terms of options, you can either do single box or dual box, and I've kind of touched on some of these points already. It's single box, it's convenient because it's on one machine, but the malware can actually the malware can actually sabotage that machine, so that it like if you're just, say, sniffing traffic, it could change that traffic. So in certain ways it can sabotage it. Now, the advantage with a dual plus box is you get this external view, and whenever you're looking at things like open ports and network traffic, you're getting an external view where the malware can't sabotage it. Plus, it's a little bit more realistic. So in just kind of the next few steps, I'm going to just go through setting up a single box. So usually, has anybody heard of Metasploit Unleashed? A few. So they actually have, it's a free kind of online course. They actually have a nice setup of the first half of the how they say to set up the XP. If you take like the first half of those instructions, they actually it actually gets a nice XP setup so that it doesn't bug you with, oh, you need to turn your firewall on, you need to install patches. So they basically go through turning a lot of that stuff off. You may want to add some target software, which, like I have listed there, like the usual suspects, Reader, Java, Flash. And then one of the big things too is usually you may need older versions. So like two big sites for those are usually oldversion.com or oldapps.com. Those are great sites. Or if you can't find it there, you can Google, try to search for it that way. So in continuing to set up your single box, these are now there are a lot of different tools to analyze malware, and I'm just trying to list like maybe the most popular stuff here. So there are two types of analysis. There's dynamic, which I'm going to talk about here, and then there's static. So dynamic is where you're actually going to run the malware and you're basically going to watch what it does. Where static is you're not going to run it, you're going to open it up in a something like AIDE or AIDE Pro, and you're going to try to figure out what the malware is doing without running it. So with dynamic tools, some of the top ones, this and a little bit on the next page is Process Monitor and Process Explorer. These are tools from sysinternals, which Microsoft bought, I think, 2 years back. So those are two great tools to start out with. Wireshark, which is for doing network traffic analysis, and RedShot, which is good for just taking, especially on Windows systems where you take a shot of the registry, take another, run the malware, and then take another shot, and then you can look at what the differences were. And I have links to all this stuff there. Three other tools that are useful is Tcp View. This is just doing the same thing like netstat minus -an, but it's on a GUI, and it can track things, and then you can save it to a text file. So there you can see if the malware pops up like if it opens any ports. Malware analysis pack, which isn't officially maintained anymore, but they have a lot of utilities. Kind of the two of the main ones are fake DNS, and then there's a lot of great right-click options, like you can just right-click on it and you can get the MD5 hash, or you can right-click on a file and run strings on it, or submit it / compare to stuff that's on VirusTotal. So the fake DNS one, this is where you actually, it'll run this pretend DNS server so that whenever the malware says, hey, give me the IP address for www.mycncchannel.com, this DNS server says, oh yeah, sure, and then it gives a fake response so that it thinks most malware will do that so that they can test, hey, am I connected to a network? And then kind of the other big one, which is written by some of the guys that work at Mandiant, is fake net. So this does basically the same thing as fake DNS, but it does a whole bunch of things. So DNS, HTTP, SSL, or you can set up just sort of a dummy listener. Like if you run strings on a file, what that does is it'll go through an exe or a DLL, and it'll pull out any printable like ASCII characters. And so if the malware isn't obfuscated well, you can see things like web addresses or IPs, or maybe ports that it's connected to. And so, or if you use Tcp View the first time you run it and you see that it's opening a certain port going to this server, well, you can use FakeNet to emulate that so that the malware thinks that it's in an actual environment. So then we talked about dynamic analysis tools, and then there's static, which dynamic analysis is relatively pretty easy because it's sort of trial and error. You sort of run it and then you set up all these things all around it to just see what's going on. Where static analysis is you're not running it and you're actually opening it up in a disassembler, and you're trying to figure out what it's doing by reading the assembly instructions. Although tools like AIDE and AIDE Pro definitely help make that a lot easier to read. And this is like a static analysis. It's more, you can have maybe like a general methodology that you follow, but it gets to the point where it's more of an art. You just kind of look at it, and after you've done it 5 years, things just, oh yeah, they're doing that, or they're doing that technique. So it's definitely a lot harder, and that's why this is sort of a 101 intro. This is where if it would get to the point where you would really need to do some heavy static analysis, that you would want to hand it off to the guys that do reverse engineering or malware analysis full time. But there are some basic things that you can do, and also for deobfuscation purposes, you can use these. So there's AIDE debug, which is free, which is just a basic disassembler. There's a plugin for AIDE called AIDE dump, and then what that allows you to do is read the malware or any processes out of memory. So a lot of malware will be obfuscated or encrypted. Well, the malware itself is going to have to decrypt itself so that it can run, and it's going to run in memory. So what you do is you run the malware through AIDE debug, pause it, and then you use AIDE dump to pull the malware out of memory, and so you've basically bypassed their encryption or packing or obfuscation techniques. And AIDE Pro, there's a free version which you can do some basic stuff with, but you also have their, I don't know, does anybody know how much a license to AIDE Pro costs? It's fairly expensive. But for doing just basic stuff, I think just using AIDE is fine. And then bin text is another great editor for just doing strings analysis. So then to just kind of finish off, you'll probably need some sort of text editor. So you know, I mean, you can just use whatever one. The one that I happen to use more often than not is this 010 editor. But you can use whatever you want. And then there's also specialized tools depending on the type of file it is. So Didier Stevens has several Python-based tools for doing automatic analysis of PDF files. And there's, you know, as you can see there, there's Swift tools for Flash, and there's a lot of other tools for Java and JavaScript. But you know, depending on what you need to do, you can just search for them and find the tools that you need. I mean, from a tool perspective, this is just sort of a baseline or a survey of the tools that can kind of help you get the job done. You're going to come across stuff like every day where you're going to have to go, oh, well, I need a tool. You know, this malware is doing this weird thing here. I need a tool that kind of helps me read that or whatever. So you'll constantly, you know, you'll build your malware analysis VM, and you'll constantly be adding stuff to it because of different things that you need. So then the last step is just to configure your VM, not host only. Make sure that it's on that secluded network that you created, so that it doesn't have network access to the host. If you need to get the malware on the box, there's several ways that you can do that. So you can temporarily put it into NAT mode so that you can download it from some file drop site. You can use CD write once because you don't want things being written back to the CD and possible bad things happening. And you can use USB keys. Obviously, you know, you need one with a write protect switch, because you know, you're putting malware on this box, and that malware may do stuff that could write back to the USB. So you got to be very careful, and they used to be fine. Like every USB key came like with a physical write switch. Now there's like nothing. So you have to, but they're not that bad. You spend $30, $40 for 4 gig, 8 gig one, and they actually have a physical write protect switch. So it's something you may have to invest in. So you get your analysis box set up. So you snapshot the VM so that you have something to revert back to after you run your malware. So what a lot of people, depending on how complex you want to get, you can add in this second server, which usually serves as some sort of a gateway. So you would have to go into your analysis machine and manually set the network so that it's using this fake server as its gateway. And so this allows you, as we talked about before, malware can sabotage the actual machine that you're running it on. So this allows you to get more of an external view in terms of network accessible things like packet captures. You can run Nmap or other tools to kind of see what ports that opens up. Let's see, and you have this base machine. You'll have to put some servers on it. So depending on your initial analysis of the malware, you may have to put like a DNS server or HTTP server or whatever the goal of your analysis is. And then install your basic network analysis or network forensics tools, take a snapshot so you can revert back to it. The nice thing about the fake server is this distro by Lenny Zellser called Remnux. And actually last week, or was it earlier this week, he actually released version 4. His prior release was probably 2 years back, so a lot of the tools on it were getting a bit dated, but it was still kind of like the go-to tool for those that were doing malware analysis. Somebody just tweeted. It was definitely the tool to go to, and it's nice. It's been a few years, but he's updated that. But they actually have tools for basically doing the dynamic analysis. So like I talked about, this is a ready-built server that has things in it so that you can emulate all the network services that you want. It's very easy. You know, it's just there's an ISO, there's a VMware image, and now they have an OVF image, so it can run on like if you want to run it on VirtualBox too. So very nice distro for doing dynamic analysis. And then you can also just load your malware onto this distro, and it's Linux, but you can do some basic static analysis where through some of the tools that they have there. And it's also good if you know, like if there's a website that you wanted to go out and it had some malicious JavaScript or something like that, you could pull it down and do some basic automated analysis of or static analysis. So this is a snapshot of what it looks like. You know, it's your basic Linux. This is the prior version. The other one that a lot of people use is the Rob Lee created the SANS Incident Forensic Toolkit SIFT. It's more focused on reverse engineering and forensics, but it has some tools that can allow you to do static malware analysis. And this is just a picture of that. So probably like the big open source tool that a lot of people use is Cuckoo Box. So what you do is you install this Cuckoo Box system, and then on top of that, you run your malware or your victim machine, and all those tools that I talked about. Cuckoo Box kind of has those in, and it's all built, so it'll capture all that same stuff, and it's a layer under the OS. So the malware has it's an additional barrier so that the malware can't sabotage the results that you're collecting on that victim machine. And these are just some of the types of data that it's captured. Now there's also commercial versions. So this is open source, and obviously your victim, you would have to get, you know, your Windows XP or your Windows 7, you'd have to get that. But there's similar to Cuckoo Box, and I'll touch on some of them in the next few slides. But there's commercial versions. So like if you work for a big company and they want support, things like that, which I'll get to. This is just a picture of Cuckoo. All right, so now you have your whole environment set up, you know, whether you went for a single machine or having a second machine with that's sort of acting as a gateway. Maybe you went, probably in most cases, you went with a virtual infrastructure. So so that's all set up. Now, you know, what's the methodology that you're going to go through? So I've kind of broken it up. These are my 3 steps, and not in all cases, but you know, probably eventually as I continue to build this deck out, each one of these will have like 20 sub-steps, but but it's still an easy 3-step process. So the first one is triage, and I should have put this on 2 slides, but I forgot to. So now you don't have to do these in this exact order here. This is just, you can kind of move these all around some, but kind of the first step. So if you can do it, you can run it through an external sandbox services, and that'll give you some quick and dirty results. Just give you an idea of maybe what the malware is doing, and then that can maybe lead you in the right direction of, all right, I'm going to focus on this area. I don't have to focus on all those other things. Some of the online tools, you know, the big ones are probably Norman Sandbox, GFI Sandbox and Anubis, and there's also threat experts. And most of those, you can use their online tools, but if you're a big company, you can actually buy their commercial versions too, and you can bring them in-house. Because a lot of large corporations don't, hey, we have this malware, we just don't want to upload it to some site, have it run, they want to keep it internal. So depending on the size of your group, but if you can't do that, so kind of the general process is just doing some quick and dirty stuff. So you'll use one of those different, like one of those right-click options from the malware analysis pack, get the MD5 hash, and then you can go to virustotal.com and do a quick search of, has somebody else already submitted this? And then that does a quick analysis of it, and you can find out certain attributes to the package and what it's doing, if it's packed or obfuscated, how it's compiled, and even when it's packed or obfuscated, it usually even tells you like, oh, it's packed in this format, so you can go find the depacking tool or whatever, kind of unpack it that way too. So that can kind of your first step. And if needed, you could do some initial analysis. If you're doing this on, say, the Remnux system, you have access to all the Linux commands, so you can run file, and then that'll tell you what type of file it is. You can also open it up in any hex editor and look for the magic numbers, which are usually, these are within the first 8 bytes, you'll see they'll have the magic numbers. So the common one that everyone sees is MZ. So that just tells the operating system that it's a Windows executable. Does anybody know what MZ stands for and where that came from?
Executable is the better form.
What? Does anyone, like, why did they pick MZ to represent an executable? Okay, so the guy that invented this format, I guess, was Mark Zibalski. So, and then what about the zip file format? Usually there's a PK. Does anybody know that?
It was PK zip, but I don't know what the PK was.
Oh, it's Phil Katz.
Okay.
So, but anyway, you can actually go and there's a Wikipedia link there. They have tons of stuff there. But these are just sort of the big ones. You can unpack it. So you can use that ollie dump trick that I talked about, or you can, based on the file type, you can actually go and find something that can unpack it. Kind of one of the static analysis tools is PE Explorer. It has one of the more popular packages is UPX, and so that can you can pack it, and then PE Explorer has a function built in for unpacking it. And I only mentioned PE Explorer here because it seems that's one of the tools that we mentioned earlier, and it's a pretty popular tool that's used for malware analysis. You can use, there's several tools. So maybe you open the file up and you want to look for, hey, well, what is the tool importing? What functions? So you can go in and you can look like, oh, look, it's loading the Windows networking functions. Well, why is it doing that if this is a calculator page? Like, why does a calculator need access to network? So you can just look for strange stuff like that. There's Fileizer, which does a lot of other things, but you can use that, and you can also use the PE export tool that I mentioned previously. So then, the big thing too is you want to run strings. So you run strings, and that'll automatically pull out any ASCII printable character. So if it's not packed well, or you can basically run strings and get a good idea of, oh hey, look, here's a string, there's a website, and there's and here's an HTTP call, and then you can very quick and dirty get a feel for what the malware is trying to do, and you can use that later in your dynamic or static analysis. And like I said, you can use the map tool, the malware analysis pack, which has a convenient right-click option, or you can use bin text, which is another one that I mentioned. And then, like I said, there may be specialized tools for doing PDF, Java, Flash, or whatever the file format is. One tool that was recently released at SMUCon this past year is Mastiff. And so this does a lot of these things in an automated fashion. So you actually just have a file, you run Mastiff on it, and it'll figure out a lot of this stuff. Just run one command and you get it back. So it's still in the beginning stages, but it's definitely something to watch out for. Does anybody have any questions? So this is like step one.
I have a step before one. What are some tools that you would recommend for snapshotting and redeploying physical hardware? Because that's an issue.
Yeah, I know. Well, the big one is I'm blanking on the name now.
Well, like Chef is good to deploy, but like to save the state of the physical hardware. Like say I want to shelve that investigation and do another one.
Oh, I see what you're saying. I mean, you probably have to talk to more of a forensics person.
Okay.
So, because that gets into the. Does anybody have any? Don't you use like DD and then you have this hard drive and it's all there and
but then
it's hashed and everything.
It would you really can't restore that.
Yeah.
Well, DD, it's not really restored. Right, that's a one for one.
Right, no. I guess my point is there an equivalent of like how you can pause it and then restart it? Is there an equivalent for physical? That'd be very nice to have.
You can
Run
use
into
shadow attack to take an image of it at that point in time.
The downside, though, with a lot of malware analysis stuff, is if they're good, they're removing their stuff as soon as they realize that someone's investigating it.
Sure.
So when you pause your analysis of that, you may lose the window of opportunity to obtain that information.
Suck it up, buttercup, and just see it through. Okay. Okay. Sorry.
No, that's fine. Yeah, that's more forensics, which is an area that I want to learn more about. But I'm not there yet. I'll give a talk on forensics next. I can learn about it. Okay, so the second step, and this is an area that I sort of build out, but this is dynamic analysis. So this is where you actually set up all these tools that are monitoring it, and then you run the malware and all the tools to sort of track what's going on, and then you look at the data that all those monitors push out to get a feel for what the malware does. So these are just sort of step-by-step how to go through that. So usually, the first step is you're going to start red shot, take your registry, get a snapshot of the registry. You're going to start Wireshark so that you can look at all the different network traffic that it may be sending. You're going to start Process Monitor and Process Explorer so that you can monitor things like processes and they're like they also do some registry and I forget what else, but they monitor several things, and then maybe you run fake net if needed because that's the module that's going to help the malware think that it's on a network, and then Tcp View so that you can track all the network sessions. So the second step is you execute the malware, and and there's no real art and science here because people could write malware to sleep for 2 weeks before it does something. But usually you execute it, and then you can watch all these different tools, these different monitoring tools, and you can, all right, is anything going on? And so you can, you know, but in most cases, usually you'll run the malware, it does a lot of stuff, and then after 15, 20 minutes, things kind of calm down. So then you can just, so then you get to your next step is where you take the red shot, and then red shot, there's a compare option, so you can see all the different registry settings that it changed. You stop Wireshark so that you can, and then save off that traffic, and the same thing with Process Monitor and FakeNet. All those have logs that you can export, and you can look at them now, but then you can export those so that you can have those for later analysis. And then basically just do comparing the different registry shots and all the logs to kind of figure out what that malware is trying to do. So the next few slides, I basically do kind of a quick take through of that. So, you know, the one on the left is red shot. It's pretty easy. There's just like, you click first shot, and then the button below that is second shot, and then the button below that's compare. So it's pretty easy. Wireshark, who's used Wireshark? Okay, a lot of folks. So, you know, so I'm not going to talk about it, but just select an adapter, do start with Process Monitor. I've kind of pointed out some things there, but as soon as you run this, things will just, they'll just fill up. So depending on how long it's stopped or how long it's been running, you can, there's those buttons that I kind of point out there is for stopping it, clearing everything out, and then starting it so that you're starting from a clean slate. And so the next one is Process Explorer. You just kind of start that up, and then here's what FakeNet looks like. So you can see it's, you know, it's pretty easy. They basically say, hey, so it's running. You can do, whenever you're done using it, you just hit Control-C, and you can see it's just starting up all these different services, and then it's just listening. And this produces a PCAP file too, in its output. So then you do TCP View, and you can actually see, like, here's a bunch of the FakeNet stuff that it started with. So then you, like I said, you just double click it. Like with an EAXE, you can just double click and run it. With with DLLs, there's this, you have to use the run DLL 32.exe, then you put the DLL name, and then any export requirements if it's needed. So, but basically you can use something like PE Explorer to go in to the DLL and figure out, oh, well, what functions does this executable thing have? And then it'll tell you all the different arguments that you can put in. So an example, once you do that, is, you know, you're going to run this, you know, I think I got this out of the Practical Malware Analysis book, but it's rip.dll and install. So you would have used PE Explorer to go into the rip.dll and see what export arguments it supports. But you basically run it, and then you just watch all your monitoring tools. And when the activity dies down, whether that could be 15 minutes or 2 weeks, you know, it can be trial. I mean, a malware analysis is something that's meant to be trial and error. So, you know, like, you do this for 15 minutes and it doesn't work. And the nice thing about VMs is you can just be like, oh, revert to my snapshot and do it again. And maybe you'll have multiple snapshots. You know, oh, I'm going to let this one run for 2 weeks or whatever. So just watch it. So then you kind of get down into the spin down phase, whatever you want to call it. So here is where you click the second shot and do the compare button for red shot. You can, you know, stop capturing packets in Wireshark and save those off. You can click that button to stop Process Explorer from looking at data, and then here, like I said before, you just hit Control-C, and that stops that. So then you save your logs for future reference and you analyze. So, and I don't really necessarily have a process for the analyze part, but I mean now, like a lot of people, it's more of a gut feel, you know, you can kind of go in and you can look, you just look, oh look, this evil.exe, it opened this port, it's trying to connect to this thing. Look, I have the PCAP of the data that it's trying to send. So you just start, you have all these puzzle pieces and you just start putting them together. So we did this kind of malware analysis, you know, triage, and then we did dynamic analysis, and then now you get into the static analysis. And being sort of a intro course, static analysis is very complex. I mean, so you can do some basic static analysis, but you know, it really takes, and I mean, it's a very specialized field that you really got to focus on. So I'm not going to focus too much on it here, but from the people that I know that do static analysis, you know, you basically open it up in something like AIDE bug or AIDE Pro, and you let it do its analysis, and then you just stare, you know, and then stare at it some more, and a little bit more, you know, and eventually, you know, you stare at it long enough, you'll start seeing patterns and things like that. And the nice thing too is you'll have all this dynamic analysis that you've already done that can help you guide to maybe focus on different areas of the program or of the disassembled program. So the last part of this talk is to basically go, you know, where to learn more. So you're definitely not going to, you know, listen to me babble for 51 minutes here and know how to do malware analysis. So you can definitely, you know, I'm going to post these slides. You can definitely use that as a start. But the question is where can you maybe get into it more? So the opensecuritytraining.info, they have a lot of free courses that you can take. One of theirs, they have a whole curriculum set up for malware analysis. So kind of some of the things that we talked about today was dynamic, static analysis, but you know, maybe, you know, things that you may want to understand to really get into is take a course on assembly language, take like a more formal reverse engineering class, and then there's some other areas like memory forensics, like that's a big area. But they have a great curriculum there. So these are just some things that I pulled out. So this is the assembly language class, and then also the reverse engineering software. And some of these, they have all the slides and the labs you can download. Like they'll have malware bad files that you can analyze, and some of them will even have videos too. So you can actually, instead of trying to read through it, at least you can watch a video. Now they have the reverse engineering malware course, which is based on, like the practical malware analysis book is probably kind of the de facto go-to book for people that want to learn more about doing malware analysis.
Who's the publisher on that? You know?
No Starch.
No Starch.
I don't know. No Starch.
Thanks, sorry,
No Starch is the publisher. And at one point, I had found videos of somebody giving this course, and I cannot find it. It's totally pissing me off right now. But, so the other things, if you're in the DC area, I'm involved at Nova Labs, and so we do kind of a monthly session called the Binary Bash. And this is just sort of, we get together, we load up a few, maybe somebody gives a quick intro of what, or teaches some lesson, and then we find a reverse engineering or a malware analysis file from like a contest or whatever. And then as a group, we try to solve it. And also they're starting, they also have a class that they're starting up there too that I'm involved in. So this is more of a 2-3 hour class, meets 2-3 times per month. Other resources is Lenny Zelser has just awesome stuff. Go to his site, and he has a whole area of his websites that's dedicated to doing malware analysis, and so I get that link. There's OpenRCE, which I think most people here have probably heard of. Yes. So that's more focused on reverse engineering, but it's definitely needed for doing this type of stuff. And also the kind of paying bills or whatever. There's trainings which kind of helps me with running the site. They have a malware analysis course, and then also I'm thinking about doing a talk like this, but have it be more workshop based, like maybe be 3-4 hours, and low cost or whatever. So
HackerCon's coming up.
What's up?
HackerCon's coming up.
Okay. Yeah. Definitely, yeah. But I'm looking at doing something. And so this is just my conclusion slide. Basically, there's you basically have these 3 steps, but there's a lot of setup you got to do. Once you get good at it, these 3 steps can go pretty fast. Some great resources of where you can learn more. I'm by no means the expert, but I can definitely point you to the people that can take you to the next level if you want to make malware analysis one of the next step in your career. But anyway, so that's all my contact stuff. Any questions? Yes.
How will we be able to get in contact with you to obtain your PowerPoint project?
Oh, okay. Well, if you just follow me on Twitter and read everything that I tweet. I can email. I don't know, Bill. Is there like a list that you maintain of all the people that signed up, or no?
Kinda.
All right.
And like their case, they're students. So
okay.
If you want to email me, I can make sure they get it.
Yeah, I can just say, hey, the post is up. Here's a link to it. Or if you follow me on Twitter, as soon as the post goes out, you'll have instant access to it. What's up?
Oh, so yeah, follow on Twitter. Everything InfoSec happens on Twitter anyhow.
Yeah, basically. Well, that's because no one goes to websites.
No, we don't have to
anymore. They just live on Twitter and Facebook.
Well, Reddit just got DDoS.
Oh, really?
It was up a while ago.
Okay, cool. Well, thanks. Thanks for having me.